If I asked you to measure the length of a particular object, you wouldn't respond 11. In fact, you would tell me what the units are. Is it 11 inches, 11 feet, 11 miles, 11 meters? Most physical quantities that you measure in physics have units associated with them. For example, units of mass are typically measured in kilograms, units of length are typically measured in meters, units of area are typically measured in square meters, volumes in cubic meters, time is often measured in seconds, velocity is often measured in meters per second, the units of something called acceleration, which we'll study a little bit in a later tutorial, are meters per second squared. Forces are measured in a unit called newtons, denoted N here, and a newton is defined to be a kilogram meter per second squared. Density, which you may recall is a mass per unit volume, has units. It has units of kilograms, which is mass, divided by volume, which is cubic meters. Here are 3 important reminders about units. First, always report your units. Secondly, always verify your units to make sure that they make sense. This is sometimes known as dimensional analysis. Let me give you an example. Suppose I have a sphere of a certain radius, and suppose I want to compute the volume of this sphere. Suppose I don't quite remember. I think that the volume of this sphere, if I seem to recall, it might be 4 pi times the radius squared, but I'm not certain. How can I check if this is potentially right or not? Well, let's check the units. If I look at this expression here, 4 pi r squared, well, r is the radius that has units of length, so let me measure that in meters, and I'm squaring it. So this has units of meters squared. But meters squared is a unit of area, and I wanted a volume which has units of cubic meters, so I know, therefore, that this cannot be right. And in fact, you may recall that the actual formula for the volume of a sphere is 4/3 pi r cubed. And now you can check that this thing has the correct units because r is measured in meters and I cube it, so that's cubic meters, and that is in fact the units of volume. Let me give you another example. Suppose I form a pendulum by taking a mass and attaching it to a string. I pull it back and release it, and I watch it oscillate back and forth, back and forth. And suppose I'm interested in knowing the time that it takes to make one complete cycle, in other words, back and forth motion. And a friend of mine comes along and proposes the following theoretical prediction for the time that it will take for one complete cycle. My friend claims that the correct expression is 2 pi times the square root of the length of this pendulum divided by a constant known as little g, which is defined to be 9.8 meters per second squared. That's the Earth's local gravitational field. But in any case, this is what I think might be the theoretical expression for the time that it takes this pendulum to swing there and back. How would I know if this formula is potentially correct or not? Well, we can check the units. Let's look at the units of L in the numerator there. L is the length of the pendulum, and L is going to be measured in meters. Now, little g in the denominator there, the units of that are meters per second squared. If I simplify this, this just becomes seconds squared. And then I'm going to take the square root of that expression. And so when I do that, I take the square root of seconds squared, so that has units of seconds. Well, what was I looking for? I was looking for the time that it took this pendulum to make one complete cycle, and time has units of seconds. This theoretical prediction here gives me units of seconds, so it's consistent. Now, I can't actually claim that this is the correct theoretical expression for the time for this pendulum to make one complete cycle, but I can say that it does at least have the correct units. So in physics, anytime you're deriving some theoretical expression or you're computing some quantity, you always want to verify that its units are the correct ones. My third reminder to you is that sometimes it's necessary to convert your units. Let me illustrate with an example. Suppose your car gets 20 miles per gallon and you want to know how many kilometers per liter this is. And as a reminder, suppose we know that 1 kilometer is equivalent to 0.62 miles and 1 gallon is equivalent to 3.79 liters. How do we do this conversion? Well, we can start with 20 miles per gallon. And now we can multiply this expression by the following. We know that 1 gallon is equivalent to 3.79 liters. So in other words, this expression here is effectively just equal to 1 because 1 gallon is the same as 3.79 liters. So I'm taking my original expression, 20 miles per gallon, and multiplying by 1. So that's allowed. It doesn't change the original expression. Let me continue on, though. Next, I'm going to multiply this expression by the following. I know that 1 kilometer is the same thing as 0.62 miles. So this expression that I just wrote in parentheses is in fact also equal to 1. So that doesn't change the original expression. And now, let's look at what we get. If we multiply this all out, this comes out to be 8.5 kilometers per liter. In other words, the way we did this calculation is we started with our original expression and then we kept on multiplying by 1 in order to change the units to what we actually wanted. And let's look at the units in particular. We started with units of miles per gallon. And then we multiplied by this expression. But notice that when we did that, the gallons cancel out. So we're left with miles per liter. But then we multiplied by this expression here, and notice what that did. That canceled out the miles here with the miles there. And so what were we left with? We were left with kilometers in the numerator and liters in the denominator. And hence we wound up with our desired units, kilometers per liter. Now it's your turn to get some practice. Turn to the exercises associated with this tutorial and give them a try. Once you've tried them, then take a look at the solutions to those exercises and see how you did.